I can't emphasize how impressed I am with the group that we have here for our first off workshop, and how important it is for you to understand that this came about, these group of workshops came about from the meetings that we've had with you, the companies in the WIN region, very specifically, that they've asked for this type of information be presented, and all of the workshops are driven based on requests from the different companies in the WIN region. So for this session, we're talking about return on investment, justification, cost justification. I've got a few slides that we'll be going through, and then Dr. Jan Andrews will be going through a model that they've created. Jans is a distinguished professor, as well as he's co-director for InMaC, which is part of what's out here, as well as a lot of other things. He's got an extensive background in not only manufacturing, but also education. And besides that, he's a good guy. So he'll spend the majority of the time. One of the things that's important whenever you're looking at IoT or product justification, and you all go through it, all of your managers, and you go through, how am I going to justify the cost that I want to spend on a capital item? And so a lot of your companies will set up target return on investments, which is the first line item, return on investments, or ROI calculations. You may have, again, targeted what's going to pass and not pass that suite. And those are based on tangible cost. And so those are benefits that are easy to derive from that. You can also do cost benefit analysis, which will attempt to quantify your return on investment as well. One of the more recent, and it applies a lot in the medical side of it, but it will be available to you as well, is value of investment. And it's defined as the invaluable assets that are contributed to the organization. That's critical as we start to look at integration of IoT, because there's so many things that are intangible that we need to worry about or consider as we're trying to justify the different products or different types of technology or applications in the space that we're looking at. So if you look at tangible costs, which is your hard cost, your traditional ROI, you're looking at headcount, reallocation, avoidance cost, which is in some organizations will be able to quantify avoidance cost, and others your Treasury Department or your capital expenditures will not include avoidance cost. It's a side factor, but if you look at GAAP accounting, it says avoidance cost isn't something that you can measure because that's anticipatory, like intangible, but a lot of companies will include that. Your increased in productivity, recruiting or trading, avoiding cost, and other types of things are all tangible costs. They're things that you can measure and directly measure. So if you're looking at a sensor on a piece of equipment, you can measure the impact of that productivity or increase in productivity, okay? The things that are harder to do and where we have concerns about, I think, are the intangible cost. How can you evaluate customer experience? Do you have a lower customer turnover rate? And is that as a result of the new piece of equipment that you've installed? Is that a result of the new IoT component that you've installed? Or is that because of something else that you've done out over on this other side, where you've improved the quality of customer service, but you don't know, is that because of what we've done here, or is it because of the integration of IoT? Okay, Internet of Things or sensors or whatever. That's where it gets really hard to measure and where on an ongoing basis we need to start adding that to that mix, because the more, if you look at technology and how technology is progressing over time, the more that we're going to have more and more of those aspects of the intangible cost or intangible savings that we need to look at. Some of them up there is, again, are customer experience, faster time to market. Everybody hears what Amazon's doing in terms of improving the time to market, where they're doing anticipatory, they're shipping stuff to you before you've even bought it yet, because you went in and you had an interest in their website. They're garnering that, and the product that you ordered or that you haven't ordered yet is halfway to you before you go in and place your order. If you don't place the order, then it'll be rerouted to a fulfillment center that's close by. But that's another way of proving that. But how do you put a value on that? Okay? How do you put a value on that specific component for your clients or for your organizations if you're wanting to improve, or if you're wanting to say this helped us by X%? That's tough to do. Okay? And I can tell you, I don't have all the answers for that, but I think there are ways and methods that you can go by and quantify that. One of the ways would be to look at the amount of products that have anticipatory shipments, and then how much are actually purchased at that stage that otherwise you may have lost because of turnaround time. What's your competition doing? Okay? If Amazon's giving you same-day delivery and Walmart's now giving you next-day delivery, where are you going to buy it from for the same price and no delivery cost? So those are things that we need to think about, because those are the types of things that each organization needs to understand the value of what that is, and place that value on the return on investment. Okay? Banks now have not moved to that space yet, but I think that there at least conversations are occurring of not only return on investment in terms of capital expenditures, but also value of investment. Okay, so those are things to think about as you move forward and start looking at these different types of techniques. And we'll spend, on future workshops, we'll spend more time, more in depth, but my fear was that right off the bat, I didn't want to bore you with a lot of accounting and finance stuff at 8 o'clock in the morning. I didn't think that would be appropriate, but I wanted to plant the seed of value on investment, because that's critical as we look to move forward. Okay? With that, I'm going to ask Jans if he will come forward. I'm not going to read the other things up here, but there are things to think about, and this list of intangibles is growing on a day-to-day basis. Okay, Ted, the slides are going to be available with approval, and we're also just as FYI, we're also taping all of the sessions, and they will be available because you signed up. We got your email addresses. When they're available out on the website, we will also email you so that you know that each one of the presentations are available, so you can share it with your colleagues when you get back to the workspace. Okay, Jans?
Thank you very much, Steve. I have this one here. Do I need that one or this one?
No,
works?
You get that, and this runs that. You
okay.
got it?
Yep.
Okay, pardon me.
So good morning. First of all, also thank you for coming. When we do things at university, when people come from industry, we feel happy. So thank you very much. I was given this title, Transition to Industry 4.0, Return of Investment. Yes, you heard what Steve was saying. But I think many, maybe not a big company, but small company, they say, but what's in it for me? Is there really a value? And I'm so old, so I've lived through lean manufacturing boom. And at that time I were in industry, and gosh, now we have to employ even more people. For now, Volvo, they do and want us to have lean manufacturing. And today no one can live without it. So there is always the question, and who's going to tame the horse for us? And this is, I think, an important part of when we discuss, when we have meetings like today. Just to give you my background, this is about 60 years, 50, 60 years ago. I was born on the manufacturing floor. My parents started a company when I was born, and that's where you spend your day, out in the garage with the parents, and this was in plastic processing. I took off. I was tool maker for some years, then went back to school and got my degree. Came back as CTO. Now it was 400 or 500 people. Now you were facing the real issue in a supply chain, but this was in Sweden, so Saab, Volvo, ABB, Electrolux, those kind of company. I then got on the faculty at University of Washington in Seattle in composite material, moved to Lausanne, developed in research. What was my research? Can you imagine? Here you saw high performance, high volume. How can you take high performance into high volume. So that had kind of been an overall direction. And high volume, then you immediately come to automotive industry. Worked with a business school on how do you implement that, seeing from a business perspective. I led R&D for America's Cup over a number of years. That's about making one, but one that is very good. And before coming here, still had my research group in Switzerland, started a company in the field, and also I'm still working for the Olympic Committee, new technology impacting the level playing field and safety and so on in sport. This is a little bit what I will cover, talk a little bit the use of Industry 4.0, seen from production, manufacturing optimization, competitiveness, and maybe one or two slides about the test bed that we have here. So you heard here Amazon. The product is already on the way to you before you even order it. It's a rush to come to the market first. If you're on the market first, you have a more modern product than your competitor, and you can. And if you look up here, if you take aerospace, 10, 15 years just to adapt the technology, of course, due to safety and regulations, but then the market is pretty good for a long time. If you take automotive, used to be 2, 3 years, now it's 6, 7 years, and one platform length, or it's maybe, or model length, we say 10 years. Sport is very quick, rotating, not much research, but they implement very fast, very good on that. And it's performance driven, more than safety driven many times. Consumer electronic, even faster, and down here you have fashion industry. But a lot of those things start to, we don't change car due to the muffler, it's bad anymore. We want a new radio system in the car. So there is a drive here to shorten this green thing as much as we possibly can. When you look at advanced manufacturing, there's a lot of different topics that we can address, but let's focus on that one, implementation speed. And this is discussion with that is a good friend of Purdue, is CTO of Boeing. And this is inspired from discussion with him. He said, when we have a new approach to making a new airplane or part of an airplane, the time from requirement definition until we have an optimized supply chain, it's way too long. And he more or less said, don't even bother to come to us if you have a serial approach to this. How can we do it more parallel? And now it's going from maybe 15 years down to 7 years. And it's easy to say, but how is it done? Of course, when you see this, you say, yes, this is where we like to put out all our favorite words of Industry 4.0. I don't want to say them all even. But this is words that you hear flying around. But how do we make sense of it? And when it makes sense, it's coming down to how can we justify it normally in cost and value. That's what at the end of the day. If I don't save money on it or have intangible or tangible benefits, it's not worth it. And of course, part of that is also education of workforce. When I talk workforce, I don't just talk here, I also talk up here. All guys like me, we have a tendency to not change too easy. Young people, they are more prone to do it. Okay, all this said, I put together a slider. I said, this is how I feel. What is a competitive company? What is competitiveness? And I call it, we are in some kind of stage of Industry 3.5 right now. Yes, productivity, flow, and yield. How can we maximize the flow through our production and the yield out of it? And I, as a person, I've had a chance to spend a lot of time with Mr. Doug Mansfield here from Kirby Risk, and seeing what's going on in this complicated manufacturing. This is not obvious, definitely not obvious. For this, we need a very agile setup. We don't need to invest every time we get a new order or a new product. No, we have to say, how can we be agile in what we have? Manufacturability, course, how do we design for manufacturing? Things that we start to lose a little bit. When we lose manufacturing, we also lose a little bit design for manufacturing. And I think this is key to keep that competences both here and elsewhere. Due date precision. Now we need, we need equipment maintenance. We will have a presentation on that. How can we predict maintenance instead of, no, we have to stop for 2 days where we have to repair. And quality assurance, we have to make sure all the fancy things we have at our machines, can it be used and do people know how to use it in an optimal way. If you are good on this, we will normally have a very successful company. If we take, now I take in a big company organization, how do they start if they have a new product or a new process coming in? Yes, they have to start to make some sample from this new material or process, do some test coupon, get some design allowables. Now the design office can start to work on it. And then they start to choose material and process, set up a manufacturing design, do production plan, and then you have some kind of cost control. This is the step you go through, say, Boeing or any other big company. What do they do today? Throw it all in to some kind of data analytics. It's PDF forms, it's handwritten documents, and then try to punch it in a computer. And then there sit the boss. At the end, he have all the information, but he can't make sense of it. We have to structure this in a better way. I don't say we are there yet, but this is just the direction I think we have to go. And what we mean by having a digital thread, anything out here should have a digital connection to what we do here. When we make our design allowables, what does it mean out here and vice versa? Now it's people dependent, but can we make it more dependent on where we can use digital information by connecting it? Just for your information, I did this with Boeing person. After half a year, they are there. After 2 years, after 5 years, and we said, want to halfen this. Here is a big part to be done. So it's easily 10 years to that, and this should be shortened. And this is an area we work on, new way to handle data in these different clusters of operation along the line here, and put it into data analytics and how we store data, how we administrate it, and how we make some decision-making tools out of it. Then we can start to talk about. This is a little bit Industry 4.0 in a value. If we can go in that direction, I think we have value to offer. I'm going to give you an example here. It's actually, test bed is just the other side of this wall, and I'm going to give you an example of a part that we are making there. We use that as a test sample. Is to how do we get continuous fiber into injection molding? Not cycle time of 10 minutes, but 45 seconds. So first we have to put the carbon fiber around so we get the structure. This is now the full load-bearing structure. And if everything works, we can, if you want, we can go out and look afterwards. This is the process. You have the carbon fiber coming in, it gets heated up, go through, it's kind of a large 3D printing cell where you lay up the fiber. This is a little bit slow. It's done for safety reason with all students, and this is, of course, you that work with robot, you know this go much faster and so on. I should speed up the video actually. And what you do now, you take out the part. You're well familiar with how you operate a machine with a robot, so that's nothing new. And then it goes to an, this is an, like a measurement system that scan the part, and you have all the dimension, the quality follow-up on it. So this is an example of a part that we use for our, we say, understanding of it. So now, how can we put dollars and cents to this? Of course, when we do now, we say cost analysis, we look at the manufacturing cost primarily, and here is the different cost drivers. So there is the variable cost, there is the fixed cost, and including there is of course the investment of equipment coming in. And how can we start to do comparison on this in a more digital way? So from the design process, we have some geometry and volumes and that type of information. We have cost that we have on different variable or fixed costs in our operation. And now we say, which process are we going to use? Can we use a highly automated process with robots everywhere, or we should use a more manual operation? Of course, that's depending on volumes. So what we have developed, worked on that for many years, primarily actually with Daimler and Volkswagen before moving here, is a drag and drop. Each, we maybe have 50 different processes that have cost. It has space, electricity, water need, and wastewater produced by it. And we drag and drop this into a process. And now it comes in with all its related databases. And then it's connecting it. And we get cost segmentation, cost per annual volume, and also depending on the discount rate you have in your company, what is the return of investment? So now you can start to do judgments. And I don't like this, I'm going to go to this instead. Here is take out some robots, I'm going to put in manual. Which is best? And so typically what you get, cost segmentation, what is material cost, labor cost, tool cost, investment cost, and so on and so on, and you can compare. And depending on the volumes are going to produce, this case is an automotive example. When you have this here, it's typical when we go over the cycle time, what we can do from 3 shifts. We need a parallel investment line. That's why cycle time of 1 minute is so important when you go to high volume, for that will kill you otherwise. But you know this. What we also do, we say now all this information is great, but we have to move it very close to the production floor. So people out in the production can see what is the influence when I change something. Typically change cycle time, or there is a robot, we say now we have to use it elsewhere, we put in a person there instead, and vice versa. Here is the different step in that production of that part that you saw. Preforming and bushings, here is the cost, we are at 225. If we go to a manual, we say less automated, low automation case, it's actually cheaper, for now we don't need to invest in the robots. But of course, in the next step it hits us, for now we have labor costs coming in then. And now you can follow the high automation case and the low automation case all the way until we have a finished part, and we go from 394 to 631. And this is the cycle time change in this particular case. Now move this from the offices down on the production floor. There's no one in the company that they do everything with good intention, but sometimes it's difficult to, is it good or is it not that good what I'm doing? So what we have here on the other side is test bed, where we can have full production set up for polymer and composite, and then for metal is also, we will have the full opening of this at the end of the year. If you want to take a peek later on, you're welcome. But every equipment, every position here have a sensor. For you need now information. And not information someone going with a timer and this is information about water flow and an electricity need, and a labor need, and all connected. And we take this then out. So on the screen there, we can follow the production, but also follow the cost. Any changes, it will show up here. And there is a red line somewhere. Now we lose money. Here is when we earn money. Doug always said, I know everything, but I don't know where I lose money and where I earn money. Where is my problem, and where have I a chance to influence it? And I think this is, the closer we can move this to more people in the company, the better it is. But this was in the company. Now we say we are in a competition also with outside, other states in the United States, or also globally, we are in competition. So we took this cost study. Actually, the person just finished. We have 2-3 people working on that, and he just finished his PhD on this one, so I have taken some of his slides. If we look at electricity costs in the United States, red, it means expensive. Green, darkest green, is the most favorable. Yes, we are here. We should not produce in Alaska. Maybe not in California either. Yeah, 5 minutes, yeah, it's about right. Water and wastewater, where is it the most favorable places to be in the United States? For this is all coming into the cost modeling, those data. And plant operation cost. Now we start to see, we start to be pretty dark green here. It's good news. And cost of living, we have more money left over in our wallet here than other places. Moving from Switzerland to here, it's obvious, I can tell you. And so now if we look, if we have a highly automated, with robots everywhere, there is no dark plant, there is just people walking around, it's an extreme, or we have just people doing all the operations. So we look now, we see the high automation case on a global scale. Yeah, I'm not a good representative. Sweden and Switzerland is pretty bad. Huh? It's not where you, it's costly. Here we see we have a spread over United States. And if we're going to move something from Asia to here, even in a high automation case, maybe 55, on this specific part, 55% more expensive. If we take a low automation case and we compare the two, if we're going to move it from Asia to here, it's going to be more than double so expensive. And here it's also coming in, sometimes the raw material is cheaper in Asia than we pay for the same material here. But of course also now shipping and logistic cost is coming into it. So if we're going to move something from a high automation to a low automation, it's about the same here. For us, it's a much more expensive case. So that is talking for high automation makes sense here to stay competitive. But it's not just about justifying with a return of investment, it's also access to capital. I've grown up in a tier 1, tier 2. What is the biggest discussion in board meeting? Is access to capital. And now we can't do it any better. Now it's zero interest. So there is not much more to do with that. So what to summarize it up, what we're doing here within the WIN project, yes, we look at the full design, we look at predictive maintenance, you will hear more about that, and how we take all this into cost, dollar and cents, and in a production setting to stay competitive. And what I mentioned about this global competitiveness, I think is very important, not the absolute number, but what order we should go after. What makes us more competitive? We are in a good region. It's not that we are, say, we can't do anything for it's too expensive here or anything. No, we are in a good region. So it's a chance to influence it. Okay, and then there is research project here. There is the test bed, all the sensor works done in the Burke Center. supply chain with a business school here, Brannert, and workforce development that we are emphasizing. So I hope over the years are now hold us accountable for this. We have to deliver on these kind of things. And I think this is the first kickoff meeting. Okay, thank you. Yeah.
John, so usually when you're going from automation, down to manual, there's a cost of quality.
Mm-hmm.
And can these sensors improve that cost of quality and continue with the manual low volume case to say decrease that differential?
Before you answer, would you repeat the question so we get it
Okay,
on?
so when we go from high to low, do we have an influence on quality? Many times, yes, for now it got people dependent.
Yes.
And if we have people from a Japanese company, there it said quality is not anything you control, it's built into the process. But you saw we have this scanner. That's a way to handle these variations with a manual situation. But on the other hand, we have a higher flexibility. When we have a low automation, as soon as we start to put a lot of investment around the machine, we lose some flexibility and can be justified. But quality is definitely one. And now we have so many techniques. Actually, some of you might know Hexagon. They are investing here now with all this metrology stuff into our equipment so we can have good quality follow-up. But I agree with our Japanese friends. Quality should be built into the process and not controlled up. Yeah.
Are there other questions? Okay, thank you very much.
Thank you.
Nicely done. So the next